Hello everyone. In the November 2017 Additional Maths O-Level exam papers, there are some questions which the majority of the students frequently make errors in. So in this video, I'm going to uncover some of the actionable tips and tricks to help you reduce errors in these questions. My name is Bell Huang, founder of IB Super Tutoring Center. We help O-Levels, A-Levels, IP, IB, and IGCSE students accelerate their learning through our 4-piece learning system. Hello, I'm going to start with the actionable tricks to score an A1 in the O-Level Additional Math exams. So for paper 1, in the Additional Math exam 2017, let's take a look at some tricks that you will need to know. Okay, for example, in question 2, part 1, students are asked to sketch the graph of y equals to 4x to the power half. This is a question that a lot of students find really challenging because they're not sure how the graph looks like. Well, it's not as difficult as it seems. Well, you can easily break it down. First of all, draw a box, right, with x and y coordinates. So put in a few coordinates to test the points. So for example, substitute x equals to 0. Use numbers that you could potentially square root because you have a square root here. You don't want to have numbers which you cannot simplify easily. Okay, another possible number you can plug in is 4 because you can square root 4. And finally, the possible number you can plug in is 16. Right? Because square root of 16 is 4. Okay, so now let's substitute that in. If we substitute 0 into x here, you're gonna get square root of 0 is simply 0, and multiplying by 4, you get 0 as well. Square root of 4, on the other hand, you get 2. 2 times 4, you get 8. 16. Square root of 16 is 4. 4 times 4 is 16 as well. Okay, great. So now you can roughly sketch this out. You have 16 here on the x-axis and 16 on the y-axis here. Okay, let's put in the number 4. So let's split this half. This is 8. 4 would be somewhat here. Okay, and halfway mark, this is probably 8. Okay, so when x is 16, y is 16. When x is 0, y is 0. When x is 4, y is 8. Okay, there we go. We can roughly figure out what this shape of the graph will look like. There you go. Question 2, part 2. In this question, students have to find the intersection of two expressions, y equals to 4x to the power half and the line 4y equals to 7x plus 4. The key concept that students have to use here is simultaneous equations through substitution. Very frequently, students will try to replace the y in the second expression with 4x to the power half. This is not the best way of doing it because it's very long and tedious, especially you have to manipulate the square root x. So a better way to go around it is to first make the x the subject of the formula in the first expression. So y equals to 4x to the power half. Try to rearrange 4, move the 4 below, equals to x to the power half. Square both sides. Alright, then you have y squared over 16 equals to x. Now, we shall substitute the x in the second expression with y squared over 16 instead. So you have 4y equals to 7, y squared over 16 plus 4. Okay, let's multiply throughout with 16. In the next step, to remove the denominator, we get 64y equals to 7y squared plus 64. Now I shall move everything over. So we have 0 on one side. Okay, great. Now I can factorize. So 0 equals to 7y, y, 8 minus minus, y equals to 8 over 7, or y equals to 8. Now I substitute back into the original expression, x equals to y squared over 16 to find my x because I need to find the coordinates of the intersection. So 8 over 7 squared over 16, 64 over 49 over 16, I get 4 over 49, or 8 squared over 16, which is 64 over 16. That gives me 4. There we go. We have the coordinates 4 and 49, comma, 8 over 7, or 4 and 8. Great. In this question, 1 over y is plotted against 1 over root x, and a straight line is obtained. So this is a very important piece of information because many students did not know what to do and what to substitute into this expression. So a straight line is obtained, so you must remember that it's probably got something to do with linear law. And you know linear law involves the form y equals to mx plus c. And m is your gradient and c is your y-intercept. So in this example, your y is actually 1 over y. Your x is 1 over square root x plus c. Okay, so in order to solve, we need to first find m and c before we can find y when x equals to 9, given all the variables here. Okay, so let's first plot y equals to 0.25 and x equals to 0.04. So 1 over 0.25 equals to m, 1 over square root 0.04 plus c. So this gives you 4 equals to m, 1 over square root of 0.04 is 0.2 plus c. So 4 equals to 5m plus c. That's the first equation we got. In the next one, we're going to substitute x equals to 1 and y equals to 0.5. So 0.5 here is equals to m, 1 over square root 1.00 plus c. So 0.5 equals to 1m plus c. So I'm going to write this down, 1 over 0.5 here. So that gives you 2 equals to m plus c. So I'm going to write this down, the second expression, as 2 equals to m plus c. Okay, so 4 equals to 5m plus c is your first expression. 2 equals to m plus c is your second expression. We're going to solve the simultaneous equation using elimination method. Then we're going to have 2, when we minus off, 4 minus 2 is 2. 5m minus m is 4m. C is eliminated. So m equals to half. Substitute back into any expression. We can substitute into the second one because the numbers are smaller. So 2 equals to half plus c. So c equals to 1/2. Okay, to find y when x equals to 9, we have to substitute the constants m and c back into the original expression. So 1 over y equals to half 1 over square root x plus 1.5. So since y is unknown, we're going to leave it there. Half square root 9 plus 3 over 2. Half square root 9 is actually 3, so it's half times 1/3, which gives you 1/6. So 1 over y equals to 1 over 6 plus, I'm going to convert this to denominator 6, 9 over 6. So therefore, I'm running out of space. So 1 over y equals to 1 over 6 plus 9 over 6, which gives you 10 over 6. So since 1 over y equals to 10 over 6, we need to inverse it to find our y. So y is 6 over 10. Okay, there we go. That's our solution. In this question 12, part 1, in paper 1, students are required to find the constant k given the equation of the normal of the circle being x squared plus y squared plus 8x minus 24y plus 96 equals to 0, and that the normal to this circle is actually 3y plus 4x equals to k. So most students have no problem in expressing this expression into the equation of a circle. However, a lot of students did not know that the normal to a circle actually passes through the center of the circle. And this is a very important piece of information to know because it will make your the solution to this a lot easier. Okay, so first let's try to express x squared plus y squared plus 8x minus 24y plus 96 equals to 0 into a circle equation. So let's group them together. So x squared plus 8x, we need a 16 here to complete the square. And we have y squared minus 24y. So we need 144 here to complete the square. So we need to subtract 16, subtract 144, right, in order to simplify this. Because we cannot just add an expression, a constant without subtracting from it. So we need to leave the values unchanged. So we have to subtract these 16 and 144. So this, when we complete a square, we get x plus 4 squared. Okay, when we complete the square for this, you get y minus 12 squared. Okay, so minus 16 minus 144, you get negative 160 plus 96 goes to 0. So x plus 4 squared plus y minus 12 squared, 96 minus 160, you get minus 64. So let's bring it over. Okay, so how do we interpret this? We know that the center denoted by C is minus 4 and 12, and the radius is actually 8. Okay, so we know that this expression has to pass through the center of the circle. So all we need to do is to substitute that into your x and y. So 3, 12 plus 4 minus 4 equals to k. So that gives you 36 minus 16 is k. So there you go. K is simply equals to 20. Makes life a lot easier, right? If you use this method, because as long as you know this concept, that the normal passes through the center of the circle, makes it a lot easier. So you can see in this diagram, any normal will pass through the center of the circle. The center of the circle is this. See, any normal will pass through the center of the circle because it's perpendicular, right, to the point here. See, any normal to the circle will pass through the center of the circle. Let's move on to questions in paper 2. What are the key things you should look out for? Okay, in paper 2 for November 2017 exams, there was one particular question, question 10 part 1, which a lot of students have found difficult. Okay, and you're given y1 equals to 2 sine x plus 1 and y2 equals to minus cos 2x. Find the amplitude of y2. Right. Many students did not know what amplitude is. Okay, as you may know, the key concept for the graphs y equals to a sine x or y equals to a cos x, doesn't matter whether sine or cos, amplitude is basically the modulus of the constant right in front of the trigonometric function. So what does modulus mean? So a lot of students, when asked to find the amplitude of y2, they think that it's actually negative 1 because of the minus sign right in front of cos 2x. That is not true. It's not negative because it's actually a modulus. So everything inside is actually made positive. So therefore, it's actually positive 1. In question 10, part 2 of paper 2, in the 2017 exams, students are given two expressions, y1 equals to 2 sine x plus 1, y2 equals to minus cos 2x. Students are required to solve for y1 equals to y2. So since cosine 2x, there are three expressions to choose from. Which one shall we use? Since you have 2 sine x plus 1 equals to negative cos 2x, it's better to try to make everything the same trigo function into the same expression. So it's best to choose the third one so that everything will be in terms of sine. So we have 2 sine x plus 1 equals to negative 1 minus 2 sine squared x. 2 sine x plus 1 equals to negative 1 plus 2 sine squared x. So I'm going to bring everything over to one side so that we can have 0 on the other side. So you have 2 sine squared x minus 2 sine x minus 1 minus 1. 0 equals to 2 sine squared x minus 2 sine x minus 2. I'm going to remove the 2 throughout so that we can work with smaller numbers. So 0 equals to sine squared x minus sine x minus 1. So you can tell from this expression that it's quite hard for you to factorize. So we have to use the quadratic formula to solve this. So sine of x here is equals to minus b plus minus square root b squared minus 4ac over 2a. Right, b is actually minus 1. So minus 1 plus minus square root minus 1 squared minus 4, 1 over 2 times 1. 1 plus minus square root 1 plus 4 over 2. That gives you 1 plus minus square root 5 over 2. That's your sine of x. Okay, so you have to use a calculator to simplify these values. 1 plus minus square root 5 over 2. So sine x could be actually equals to 1.6180, or sine x equals to negative 0.618033. Hope you can see my handwriting. I'll try to make it a little bit bigger in the next line. So clearly, this you reject because sine cannot be greater than 1. So you are left with sine x equals to negative 0.618033. So obviously in this example, you are not to include the minus when you find the basic angle, because we have to find the basic angle, use ASTC, right? You recall your ASTC diagram, find the actual values. So we can't use the negative sign to find the basic angle. So basic angle equals inverse sine of 0.618033. That gives you basic angle equals to 38.1726 degrees. And since this is negative, for sine, it lies in the third and fourth quadrant. So your answer will be 180 plus 38.1726, or 360 minus 38.1726. We have come to the end of this video, and we hope that you found the tips shared useful. Thank you for watching. Don't forget to hit the subscribe button below for more upcoming videos on how to ace the O-level examinations. Hope to see you soon. Bye!